In this video, I'm going to solve some integration problems of a trigonometric function. So in integration of trigonometric function, we use these following formulas. So it is easy to integrate some simple trigonometric function if you know these formulas. So but we have the general formula of integration of trigonometric function because a trigonometric function is a kind of a composite function. So for example, if we're going to integrate cosine of 2x dx, so as you can see here, when we're going to integrate cosine 2x, it would be equal to sine 2x as we follow the formula. But as you can see here, it is a composite function because it has an inside function which is 2x. So therefore, in derivatives, we were going to multiply the inside derivatives of a function. But here in integration, as its reverse process, we're going to divide the inside function. So what we're going to do here is first integrate the outside function, which is cosine 2x. So therefore, it's become sine of 2x. Then divide by the derivatives of the inside function, which is 2. Then plus an arbitrary constant. So therefore, it would be equal to 1/2 of sine of 2x plus an arbitrary constant. Next, how about if we're going to integrate x sine of 2x squared dx. So from this function, as you can see, if we're going to differentiate this function, answer would be equal to the outside multiplier of the function. So therefore, we're gonna represent this as our u. So we use here u in du representation and substitution. So we're gonna use here our u as equal to 2x squared. So our du here is equal to 4x dx, and our dx is equal to du over 4x. Substituting this, our represent variables to the original function. So we have integral of x sine, so our 2x squared here will represent this as our u. Then our dx is equal to du over 4x. Then as you can see, we can cancel out the x. Therefore, it would be equal to 1/4 as a constant here times the integral of the sine u du. So now we can use the formula here. So we have, so it would be equal to 1/4 times integral of sine u du is equal to negative cosine of u plus an arbitrary constant. So by simplifying, we have, it would be equal to negative 1/4 of cosine, where our u is equal to 2x squared plus an arbitrary constant. So that's our final answer. So another example, if we're going to integrate a function sine squared x, so what we're going to do here, as you can see, we cannot easily integrate this because it has a power of 2. So therefore, what we're going to use here is to change the function by its equivalent identities. So to reduce its exponent, so what we're going to use is the double angle identities. That would be equal to sine squared of x is equal to 1/2 times 1 minus cosine of 2x. So as substituting the the original function by this equivalent function, so we can easily now integrate because the exponent was reduced. So what you need to remember here is that if a sine function or a cosine function raised to an even exponent, raised to an even number exponent, what we're gonna use here is double angle identities. So by substituting the original equation, the original function, what we have here is it equal to the integral of 1/2 minus 1/2 of cosine 2x by distributing each term dx. So therefore it would be equal to integral of 1/2 integral of dx minus 1/2 integral of cosine of 2x dx. So by simplifying, so 1/2 times the integral of dx, which is simply as x, minus 1/2 times, so as you can see here, we have the inside function, the derivatives of inside function, which is 2. So therefore we need to integrate the outside function. So the integral of outside function of the cosine 2x is equal to sine of 2x, then divide by the derivatives of the inside function, which is 2, then add an arbitrary constant. So by simplifying, we have 1/2 of x minus 1/4 sine of 2x plus c. So that was our final answer. So another example, if we're going to integrate a function of cosine squared of x. So as I said earlier, if a sine function or a cosine function raised to an even exponent, so what we're going to is substitute its identities equivalent. So what we're gonna use is the double angle identities to reduce the exponent. So the equivalent of a cosine squared of x is equal to 1/2 times 1 plus cosine of 2x. So therefore by substituting its to the original function, so it would become the integral of 1/2 plus 1/2 of cosine 2x dx. So by simplifying, we have 1/2 the integral of dx plus 1/2 the integral of cosine of 2x dx. So in simplifying, we have 1/2 times the integral of dx, which is x, then plus 1/2 times the integral of cosine 2x is the integral of outside function, which is sine of 2x divided by the derivatives of the inside function, which is 2 plus an arbitrary constant. So therefore in simplifying, we have x over 2 plus 1/2 times the 1/2 inside, we have 1/4 of sine 2x plus an arbitrary constant. So that was our final answer. So next, how about we're going to integrate a sine or a cosine function which has an exponent of an odd number. So for example, we're going to integrate sine of cube of x dx. So what we're gonna do here, if in an even exponent, we use the double angle identities. So here, in an odd exponent, what we use here is the Pythagorean identities of a function. So we have here sine squared of x plus a cosine squared of x is equal to 1. So therefore, to make for us to, we're gonna substitute these identities to original function. We're gonna break down the original function. So we have here sine of square root of x times sine x dx. So therefore, in simplifying, we have here the integral of sine squared of x is equal to 1 minus cosine squared of x times sine x dx. So therefore, by distributing the sine x each term, so we have sine integral of sine x minus cosine squared of x times sine x dx. So now, in simplifying, so we're going to integrate now sine of x dx minus the integral of cosine of squared of x times sine x dx. So in the first term here, in this function, we're gonna easily integrate this one. So from our formula, so the integral of sine x dx is equal to negative cosine of x dx. So as you can see, the derivatives of the inside function is 1, so therefore it's gonna be equal to cosine x dx. We have no dx here. Then in the next term, in this function, what we're gonna use here is the way of u and du representation and substitution. So what we're gonna represent here as our u is the function which has an higher degree, which is the cosine squared of x. So our u here is equal to cosine of x. So as you can see, in this function, we're gonna write this also as cosine of x raised to 2. So therefore, we're gonna use our cosine here as our u. Then by finding the derivatives of our u, so we have negative sine of x dx. So as you can see here, we can cancel out, we can change this here to our negative, it would be equal to negative du. Our sine x here dx is simply equal to negative du. So therefore, by substituting this our represent function to the original function, we have the integral of u raised to 2 times our sine x dx here is negative du. So by simplifying, we have here, this is now the answer for the first term, minus cosine of x. Then we have negative here and we have negative here. So negative times negative, it would be equal to positive. Then the integral of u squared du. Then what we're gonna use here to integrate is the power formula of integration. So we're going to add the exponent by 1, then divide the function by its exponent. Then don't forget to add an arbitrary constant. So by substituting our original function to the u, so we have now negative cosine of x plus our u is cosine, so therefore we have cosine of cube of x over 3 plus an arbitrary constant. So that was our final answer. Next, how about we're going to integrate a function, product of sine and cosine function. So for example, the integral of sine squared of x and the cosine of cube of x dx. So what we're gonna do here, so as you can see here, our sine function here has an even exponent and the cosine function has an odd exponent. So in order this to transform to be satisfied the formula, so we're gonna break down the the function who had odd exponent, and we're gonna use the Pythagorean identities to substitute. So therefore our Pythagorean identities, it would be equal to sine squared of x plus cosine squared of x is equal to 1. So therefore what we're gonna do here from our original function is to crack this function who has an even exponent, who has an odd exponent, which is 3. So therefore it's gonna be cosine of squared of x times 1 cosine of x dx. So from these identities, we're gonna use to substitute the cosine squared of x. So therefore it would be equal to the integral of sine squared of x times our cosine squared of x is equal to 1 minus sine squared of x squared of x times cosine of x dx. So by simplifying, sine squared of x times 1 then times cosine of x, so we have the integral of sine squared of x times cosine of x minus the integral of sine squared of x times sine squared of x is sine raised to 4 of x times cosine of x dx. So in simplifying, what we're gonna use here is u and d as a representation. So because we're gonna also write this as sine of x raised to 2, and this we're gonna also write this as sine of x raised to 4. So in order as to cancel this function, in this function we're gonna represent our sine x as our u because it has the higher exponent. So here our u here is equal to sine x. So by finding their derivatives, we have here du is equal to cosine of x dx. So our cosine of x dx here is equal to du. So therefore we have here the integral of u, which is our sine x, and it is raised to the power of 2, and our cosine x dx here is du, then minus the integral of our sine x. Sine x here is represent as our u, which is raised to 4, then our cosine dx is also equal to du. So therefore it is easy now to integrate using the power formula of integration. So we have here integral of u squared du is simply as u raised to 3 over 3 minus the integral of u raised to 4 du is simply as u raised to 5 over 5 plus an arbitrary constant. Then by substituting the original function from this function, we represent as u, so it would be equal to sine x raised to 3 or sine cube of x over 3 minus sine x raised to 5 or sine of 5 raised to over 5 plus an arbitrary constant. So that was our final answer. So last example, how about we're going to integrate a function of sine of 4x times cosine of 5x dx. So in this function, we have to use the identities which represent that if we have sine of m times x, cosine of n times x, where n and m are a constant, it would be equal to 1/2 times sine, then m minus n of x plus sine m plus n of x. So therefore, to easy to integrate this kind of function, we're gonna substitute this original function by this function. So our m here is equal to 4 and n here is equal to 5. So therefore, the integral of sine 4x cosine of times cosine of 5x dx is equal to 1/2 times sine m minus n. So therefore, it equal to negative x. 4 minus 5 is negative 1 plus and plus sine m plus n, so it's become 9 times x then dx. So what you need to do here is to familiarize these identities. So by substituting here these identities to the original function we have here now, so as integrating this function, what we're gonna do here, so we have here a 1/2 outside, which is the constant, times the integral of sine of minus x dx plus the integral of sine 9 of x dx. So in simplifying, we have 1/2. So the integral of sine minus x is equal to, as our formula said, integral of sine is negative cosine, so we have negative cosine of minus x, then divided by the derivatives of the inside function, which is negative 1, then plus the integral of sine 9x is simply negative cosine of 9x, then divided by the derivatives of inside function, which is 9 plus an arbitrary constant. So that was our answer. So in simplifying this function, so we have 1/2 of cosine of negative x, then positive times negative, so we have here negative 1/9 of cosine of 9 of x times 1/2, so we have here it's become 18 because we have a 1/2 outside, plus an arbitrary constant. So don't forget to add the arbitrary constant. So that was our final answer.